Getting Ready 19. We're gonna, these first three, just factor these expressions. None of the three are done exactly the same way, so we're just kind of checking in to make sure you haven't forgotten any of these. So this first one's a binomial. The only ways we know to factor binomials are either GCF or difference of two squares. So as we look for a GCF, we see, oh, 4 goes into both of those, and they also, both terms have an x. So our GCF is 4x. 4x times what is 4x squared? Well, times x. 4x times something is negative 12x. It would be times minus 3. The binomial that remains in the parentheses, I still want to check that for difference of two squares, but neither of those terms is a perfect square, so that one's finished. Number 2, I look for a GCF. Since I do not find one, I'm going to use my magic x. A is 1 times negative 36 is negative 36. The sum that I'm looking for is negative 5 coming from the b term. To get a negative product, I need a plus and a minus. That means I'm looking for factors of 36 that are different by 5. That would be 4 and 9. I would want positive 4 and negative 9. Choosing to set it up that way because my overall sum needs to stay negative, so I put the one with the larger absolute value as my negative. These factors are x plus 4 and x minus 9. And then number 3. I look for a GCF. I don't find one. Again, setting up the magic x. This time I do have an a value. 2 times 7 is the 14. And my desired sum is 9. Positive product means two of the same signs matching this, so both positive. Factors of 14 that add to 9 are 2 and 7. Remember, those are not the actual factors that you will write as binomials here. Those are just what we use to break up the 9x. So we rewrite this as 2x squared plus 2x plus 7x plus 7. From these first two, I can remove a GCF of 2x. 2x times x is 2x squared. 2x times 1 is 2x. From the next two, I can remove a positive 7. So 7 times x to get 7x, and 7 times 1 to get 7. Since I see just what I hoped for, that the parentheses match, I have x plus 1 times my GCFs, 2x plus 7. The new stuff that we did today was actually solving equations by factoring. Now, we had different names for these. We could call them the solutions, but we knew they were also the x-intercepts, the zeros, or the roots. Okay, so we keep changing the directions as we go through the homework here, whether it says find x-intercepts or find roots, but they all mean the same thing. And we're doing that just so you get used to seeing it multiple ways. What you want to look for is first that the equation is equal to 0. It is. Is it already factored? It is. So then you just ask, what will make each one of these factors equal 0? So what makes x plus 17 equal 0? What makes x minus 22 equal 0? Well, solving these one-step equations, my results are negative 17 and 22. Now remember, you do not have to show those steps if you can solve this mentally. However, I need you to know what you're doing stands for this process, because if this had said 2x plus 17 and 3x minus 22, then these answers would be different. I would have to actually solve that and get negative 8.5 and positive 22/3. Know that when you skip this step, it is still something that you're doing mentally. There will be times when you have to write it. I think number 5, step 1, I check, is it equal to 0? It is. Is it factored? No, it is not. So it's time for me to factor. There is no GCF. So I make my X and say, all right, I want a product of negative 54 and a sum of 3. Signs have to be different. Factors of 54 different by 3 are positive 9 and minus 6. X plus 9 times x minus 6 equals 0. I do need to see this step. If we are solving by factoring, I have to see you factor it. Don't try to go from the magic x to your solutions or to your x-intercepts. What makes x plus 9 equal 0? That would be negative 9. What makes x minus 6 equal 0? Well, that would be 6. Change of directions. Find the zeros. Same thing. Solve it. Find the x-intercepts. So first step, is it equal to 0? Yes, it is. Second step, is it factored? Not yet. Look for a GCF, but there is none. I want a product of positive 12 and a sum of positive 8. Signs are the same, both positive. Factors of 12 that add up to 8 are 2 and 6. So this factors as x plus 2 times x plus 6 equals 0. So what would make x plus 2 equal 0? What would make x plus 6 equal 0? Well, negative 2 and negative 6. Number 7. Is it equal to 0? No. This is the first one that wasn't. Now, the reason we need it to equal 0 is because at this step, when you are saying, oh, I can just set each factor separately equal to 0, that is because of the zero product property, which says simply if things are multiplied to equal 0, one of those things has to be 0. Well, there is nothing that says if I were to factor this left-hand side and have two binomials multiplied equaling 7, there's nothing that says if two things are multiplied to equal 7, well, I can't even finish that sentence because it would sound so dumb. I have to have it equal to 0. So subtract 7 on both sides. X squared minus 11x plus 31 minus 7 is 24 equals 0. Now we factor. There is no GCF, so I want a product of positive 24, but a sum of negative 11. Signs are the same, both negative. Factors of 24 that add to 11 are 3 and 8. X minus 3 times x minus 8 equals 0. What would make x minus 3 equal 0? Well, putting in a 3. What would make x minus 8 equal 0? X equals 8. Now the directions say find the roots. But again, that's exactly the same thing we've already done. It's just another word for it. The number 8, it is equal to 0. But when it comes time to factor, we actually do have a GCF this time. Let's take that out. We have 3 times, now 3 times what is 3x squared? That's x squared. 3 times something is 6x, that's 2x. And 3 times something is 3, that's positive 1. But that doesn't mean I'm done factoring. Everything in these parentheses is still a trinomial that I should try to unfoil. I'm looking for a sum of, or a product of 1 and a sum of 2. These are both positive, so my factors are both positive. And what are the factors of 1 that add up to 2? Well, 1 times 1. So this should be factored as 3 times x plus 1 times another x plus 1 equals 0. Now, 3 does not impact your roots, your solutions, your zeros, your x-intercepts. But don't get in the habit of losing it or throwing it away or dumping it, because if we are talking about, hey, please give me a factored form of this left-hand side, this expression, the 3 is essential. You will never multiply this back together and have what you started with if you lose the 3. But when we get to this step where we're using the zero product property right now and saying, okay, I have some stuff that's multiplied together and the product is 0. Well, that can only happen if one or more of those things, those quantities, is 0. Maybe 3 equals 0. Well, we can't make 3 equal 0. So that's why we get to just kind of not let it affect us. Maybe x plus 1 would equal 0. Well, that would happen if x was negative 1. Now, when you start to write the next one, you realize, hey, I just did that. I don't need to do it again. What this one means is there's just one and only one root x-intercept to this equation, and that is negative 1. All right, number 9, start by making it equal 0. So I need to subtract x on both sides. Now, notice there aren't any x to the first terms over here. I'm bringing a third term. I want to write this in standard form though, meaning in order from highest exponents to lowest. So x squared, I want the negative 1x in the middle and then minus 42 so that it's actually in standard form, because all those rules we have about factoring depend on the expression or the equation being in standard form. There is no GCF. I'm looking for a product of negative 42, but a sum of negative 1. So to get a negative product, I need different signs. They have to be different by 1. That would be positive 6 and negative 7. X plus 6 times x minus 7 is equal to 0. What makes x plus 6 equal 0? Well, only if x is negative 6. What would make x minus 7 equal 0? Only a value of 7. Numbers 10 and 11 just say simply solve, because that is what we've been doing here. Finding the solutions is the same as finding the zeros, the roots, the x-intercepts. Now this first one, it is equal to 0, and when you ask yourself, is it already factored? It is. It's already written as two quantities multiplied together. Now one of them is not a binomial, it's a monomial, but that's okay. I'm ready to just go, okay, what would make x equal 0? Well, that's not an equation that needs solving, that's just a statement of fact, x equals 0. And what would make 5x plus 4 equal 0? Now here's the first one that, the first time it's absolutely essential that you actually wrote out this little mini equation. You're not going to just look in these parentheses, look at that binomial and tell me you know what x is equal. I've got to solve this. What would make the whole 5x plus 4 expression equal to 0? Well, if we subtract 4 on both sides, we know that 5x equals negative 4, and divide by 5 on both sides, x is equal to negative 4/5, or negative 0.8. This is why it's so important to keep in mind, even if you're not showing it to me, that you are actually solving little miniature equations, not simply switching the sign of what's in the parentheses. Okay, number 11. We look at this one, it is not equal to 0. I need to move everything to one side or the other. Now, I'm going to choose to make the right side 0, but it's not because there's less terms over there. It's not because I like the right side or like the left side better. But remember, we like to factor when our x squareds are positive. That leading coefficient's positive. So where do you have more of those? I have 3x squared here and only 2 over here. I'm going to cancel the smaller amount to keep my x squareds positive. At the same time, I can subtract 8. I'm going to have 1x squared, nothing to do with the 2x yet. Negative 40 and negative 8 is negative 48, and that's equal to 0. Now we need to factor. Magical x, product, negative 48, sum, positive 2. To get a negative product, I need one of each sign. They have to be different by 2. So I want positive 8 and negative 6. My factors are x plus 8 and x minus 6. So what makes x plus 8 equal 0? Only if x is negative 8. What makes x minus 6 equal 0? Only a value of 6. These last three, solving quadratic equations by inspection. Inspection is not a method. That just is telling you, hey, see if you can kind of stare at it, solve it mentally, do any little steps that you might think of on your own. Just kind of figure out what it would take to make the equations true. Now, each of these three, we're going to learn a method called solving by square roots, and that's what we'll actually use to solve them. But the idea here is if you have to kind of figure these out, work them out in your own way, in your head, you'll probably understand that square root method a little better when I do show you how to do it. If we're asking ourselves here, what makes x squared equal 36? The obvious answer would be if you plugged a 6 in there. 6 squared is 36. But remember, you can also square negatives and get positive numbers. We would also have to include x is equal to negative 6. Because see, this says find the value or values. Actually, there are two values for each one of these. How do I make 2 times x squared equal 18? Whether it's physically writing it like I am or in your head, ask yourself, well, then what does x squared have to equal? If I divide both sides by 2, that means I need my x squared to equal 9. I need that to happen so that when I multiply it by 2, it turns into 18. Well, what number squared is 9? The first one you probably think of is 3, but just like we had number 12, that could also be negative 3. Only doing those two might mislead you and make you think, oh, it's always just some number and then the opposite of that number also. Well, that's not true in something like 14 where we're squaring a binomial instead of just an x. So now I have to ask myself, what thing squared is 25? Right? If I just imagine this as a big old blank thing, oval squared equals 25. Well, then the oval would have to either be 5 or the oval could be negative 5, right? Like there's your two numbers that are opposites. But I wasn't looking for the oval. I'm looking for what x plus 2 is. So what number would I have to add 2 and make it equal 5? Well, 3 would work. But to get negative 5, what number plus 2 is negative 5? And that would be negative 7. This is definitely the toughest of the three problems by a lot. And if you weren't able to come up with both of those on your own, that's fine. This was just kind of the getting you set up to be successful in the future. But if you try out each of these, 3 plus 2 is 5, square that is 25. If you try the negative 7 plus 2 is negative 5, and squaring that you get 25. So those are the two solutions to number 14. And we're done.